Hey AP Calculus class, welcome back from Christmas break. So I'm just going to go over an overview of things to make sure you're thinking about this week and with us being virtual this week, and if we heaven forbid have to continue virtual, these rules will continue as long as we're virtual, but for this week. And then I'm going to do a quick review of section 4.1 and 4.2 that we did just before Thanksgiving break, just as a refresher, and then you'll be able to move on from there. First, all daily homeworks are due to me via email before class begins the next day. So for example, Wednesday, you're going to have some regular in your book homework that you just need to send me a photo, or you can scan it, whichever you prefer for daily homeworks. I don't care, because I'm just going to open it up, look through to see that you've completed all the problems and it's not just a list of answers and you've checked them, and then check you off for your daily homework grade. That's due by the beginning. If class starts the next day and I haven't gotten it, if it arrives after class starts the next day, then it will be considered late. So it needs to be sent to me via email before class starts the next day. For pledged assignments, now these are the ones that I'm going to grade. They must be scanned, and sometimes they're due before class starts the next day. Sometimes they're due the day it's assigned by a certain time. So, for example, you have a pledged assignment tonight, Tuesday night, and it is due before class begins Wednesday. However, I'm assigning one on Friday, and that one is due Friday evening, and the time is written on your syllabus. So you will have to look at your syllabus to see if it's due the next day or if it's due that evening by a certain time. And those must be scanned because I need them in PDF form so I can print them and mark them up and grade them and then send them back to you. Let's back to the pledge assignment. On the pledge assignment for Tuesday night, if you have questions, please email me. I probably won't check and respond to emails later than 10 to 10:30 Tuesday night. So don't wait until 10 o'clock to start that pledged assignment that's due before class starts the next day. I'm going to be generous with my help if you ask for help via email, because you're not in class to do your 1 hour of work like typical. So, and I know it's been a while since you've done this information. We are going to review it. There's a review worksheet. There's a key on SaintsNet, but it's also been 6 weeks. So if you have questions on Tuesday night's pledge assignment on sections 4.1 to 4.2, start it early. Start it at 2 o'clock in the afternoon so you can send me emails and we can respond back and forth, and I will be very helpful if you reach out for that help. Remember, on pledge assignments, you may use your books, you may use your notes, you may use the review sheet that I have put on SaintsNet on the material, plus the key so you can check yourself. So you can use all of your resources, and you can reach out to me as much as you need to. You cannot reach out to a classmate, you cannot reach out to another NSA math teacher. And that is due before class starts Wednesday via a scan to my email. After you finish the review video today on Tuesday, there is a key and a review sheet that you complete. That is a daily homework classwork check. So just send me a picture of that so I know you completed it, so I can give you your 4 points for completing that. When you look at the rest of this video, you might want to have that review sheet already printed off beside you, the 4.1 to 4.2 review, because some of the examples I'm going to do during the review time will be right off of that. So that way you can go ahead and do them along with me and already have those problems off the review. I recommend you do this review before you do the pledge assignment to make sure it's fresh. You don't have to. You can do the pledge assignment first, but the extra practice problems are intended to help the pledge assignment be a little easier and faster for you because you've refreshed your memory. I will be absent on Wednesday. This was a planned absence that I planned before Christmas break, before I knew we would be virtual, and I can't change it. So Wednesday, January 6th, there will be asynchronous lesson. There will be a video like this of section 4.3a. So you need to still watch that video during the normal class time. And then there's homework problems that we will go over on Thursday when you meet with me via Zoom. So Wednesday, you do not need to check in via Zoom because I will not have access to check in with you. You need to go online to SaintsNet. The video link will be both on my syllabus and it will be on SaintsNet on the right-hand side on your downloads. Everything will always be in both locations. So you can watch the video. The notes, the blank notes are also on SaintsNet and on the syllabus. You can print those off and fill them in like you do in class as I teach the lesson and then do the homework. To explain the syllabus, if you look at Wednesday night's homework, I am telling you to only do some problems like A and B, or A and B and C only. Yet there's a D and an E part, or there's a C part that I'm having you skip. If you read the syllabus, it says you might want to leave space on Wednesday night's homework because the C and the D problems you're going to do Thursday night's homework. So I've broken this lesson over 2 days, but you can't do the entire problem. The entire problem asks you to do everything. We haven't learned the second half of the lesson. So you're going to do the whatever parts I tell you, the A through C or the A through B Wednesday night. Leave some space. You know, if there's just a C part, leave some room to do C. If there's a C, D, and E that you have to wait to do, leave room for C, D, and E. And then Thursday night, you can come back and finish the problem. You don't have to do this, but what over the years I've discovered works best is if students can go back and pick up where they left off instead of having to have a second sheet and match it up. So that's just a suggestion as you do Wednesday night's homework. And Wednesday, since we don't have class, the way you're going to let me know you came to class and watched your video is once you've gone through the video and filled in the notes for Wednesday, just send me a picture of the filled in notes and that will count as your attendance. So you need to send that in to me. So, we're going to get started with the review. Oh, Christmas pledge assignment. Sorry. The Christmas pledge assignment that I gave out to everyone. Everyone should have that physical copy of that pledge assignment. That will be a test grade. Same pledge assignment rules as always. Open notes, open books, open old testing quizzes that are yours, and any questions you need to ask Mrs. Conrad. It is a test grade, so there are a lot of problems. I think there's 28 multiple choice and then 2 free response, if I remember correctly. You can't do all of this yet. Some of this you're going to be learning over these 3 weeks, but you can begin 1 through 6. You could do 1 through 6 tonight if you wanted to. You know how to do all of that. It is a review of stuff you did before Thanksgiving. So I recommend this week, get started on the first 6. As we work through section 3 on Wednesday and Thursday, you'll then be able to do 7, and you'll be able to do 9, and you'll be able to do 10 after Thursday's class. So and 11 as well. So as we work through each week, you'll be able to do more and more. So you can go through, and some you can already pick out and do, and some you'll have to wait as we get to them. But I don't recommend waiting until the last week. The problems that you will not be able to do until after the chapter 4 test, the problems that you will not be able to do until after the chapter 4 test are problems 19 through 25. Everything else you'll be able to add on as we go through the chapter, and some you'll be able to already do immediately, like the first 6 for sure you could go ahead and do. So get started on that so you can ask me questions as you go through this packet, because you do not want to wait till the very end. Remember, if it's turned in before Friday the 22nd, you will receive 5 bonus points on your test grade. Okay, so review, just a refresher. we're working with derivatives still, and the purpose of a derivative is to find the slope. And just a couple quick review rules. If we want to get the derivative of x to the n power, how do we get that derivative? N times x to the n minus 1. So if the function is 4x cubed, then the derivative would be 12x squared. That's the power rule. We also had the product rule. So if we have f of x times g of x, and we want to get the derivative, then it's f of x times the derivative of g plus g of x times the derivative of f. We had the quotient rule, where we have a function divided by a function, and that derivative was the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So you'll hear me, those who did not have me last year for virtual, I like to pause during my lesson to give you time to think, and feel free to speak out loud at home. It will help you recall this if you act like you're in class, even though you're virtual during these videos, to help you recall these formulas that you are going to have to just know automatically. Then we had the chain rule, where we have a function inside of a function. So for example, something like 2x plus 3 cubed. How do we get that derivative? It's the derivative of the outside. So the 3 comes to the front and becomes a square. Then what? Times the derivative of what's inside. And what's the derivative of what's inside? It is a 2. And then you would simplify that. So your chain rule. Then we also have, and to use the chain rule, how would we rewrite this so that we don't have to do the quotient rule and instead can use the chain rule? That's right, we would rewrite it as x minus 2 to the negative 3 power, and then get the derivative. Negative 3 minus 1 is negative 4 times the derivative inside. What's the derivative inside? It is a 1. And then we'd rewrite this. Or, how would we rewrite the square root of 3x plus 4 before we do the derivative? That's right, we would rewrite it as 3x plus 4 to the 1/2. And then we would get the derivative, so 1/2, 3x plus 4 to the negative 1/2. Times the derivative of what's inside, and what's the derivative of what's inside? It is a 3, and then we could make that pretty by putting the negative square root in the denominator. So, let's see, trig rules. We have some trig derivative rules. Switch to a different color for a little bit. So let's see, what is the derivative of sine? That's right, it's cosine. What is the derivative of cosine? It's correct, it is sine. Oops, sorry. I forgot her negative. Negative sine. What is the derivative of tangent? Who remembers? That's right, secant squared. What is the derivative of cotangent? Negative cosecant squared. Okay. What is the derivative of secant? Who remembers? Secant x, tan x. What is the derivative of cosecant? Negative cosecant x, cotangent x. Remember, when you add a co, they all become negative. Good. Okay, so we also, a couple other quick rules. What's the derivative of e to the x? E to the x. So what's the derivative of e to the 5x plus 1. E to the 5x plus 1 times 5. What rule did I just apply right there? Correct, chain rule. And finally, for now, derivative of ln of x is 1 over x. What's the derivative of ln of 5x plus 4? It is 1 over 5x plus 4 times the derivative of 5x plus 4, which is 5. Another way we did this was we said it was u prime over u, so it would be the derivative of whatever u is over u, and u is this item inside of the natural log. Good. So that's old review. That goes back to chapter 3. You've had 2 tests using these rules. So at this point, these rules should be second nature. We won't be spending a lot of time reminding ourselves how to do this because we've already had 2 chapter 3 tests that covered this. So then we're going to review what you did at the beginning of chapter 4, which is what the review sheet is. If you don't have it pulled up, I have it now because, like I said, I'm going to do problems from that. So then you'll have fewer problems on that to do for practice. And then that's what the pledge assignment is that you're doing tonight for homework that is due to me before class begins. And if you have questions, email me for help. But don't wait till 11 o'clock at night. I won't be checking email that late. Okay, so get started earlier rather than later. So 4.1. In section 4.1, we learned how to find critical numbers for a function. Who remembers what critical numbers are? They are where the derivative equals 0 or is undefined. So if you're asked to find critical numbers, you're looking for where the derivative equals 0 or is undefined. So if we look at the first example, so I'm using this review sheet. Key is already on SaintsNet, so you can check yourself. We'll go ahead and do example, I guess we can do example B together. Okay, so we, in example B, are asked to find the critical numbers of g of x equals x times the natural log of x. So the first thing that tells me is I need to find where the derivative equals 0 or is undefined. So I need my derivative. And what rule do we see happening here? Correct, that is the product rule. So it's going to be x times, what's the derivative of ln of x? 1 over x plus ln of x times, what's the derivative of x? 1. So we're going to clean this up. X times 1 over x is 1. Ln of x times 1 is ln of x. And we want to find where this equals 0 or is undefined. Well, we only have to worry about undefined when there's a denominator. We have to find where the denominator equals 0 for undefined. But there's no denominator, so we just need to solve this equal to 0. So we're looking for where ln of x equals -1. How do you solve a natural log equation like that? Good, you put it in exponential form. What's the base? E, what's the exponent? -1, what's it equal? X, so 1 over e is my critical number. That is the point where the derivative equals 0 or is undefined. So that's what a critical number is. Then in section 4 we talked about absolute extrema. We talked about the absolute max of a function, the absolute min of a function on a closed interval. So you're going to have to be provided a closed interval because those are going to be your endpoint possibilities. And then you're going to have to find what's called your relative or local maximums and minimums. Those are where the derivative equals 0 or are undefined. Those are where your critical points are. So you're going to have absolute maxes or mins, and they can either be endpoint max or mins, or they can be relative, or the word local is also used, max or mins. Endpoint max or mins makes sense. They're going to happen at the closed interval endpoints. Relative max or mins are going to happen at critical numbers. So where the derivative equals 0 or is undefined. So we're going to look at another example from the review sheet. So now we're looking at section 2, where it says find the absolute max or min values of the function, and then go a little further and tell whether or not that absolute max or min is an endpoint extrema or a relative local extrema. So we can do, let's do letter B again. So they gave us g of x equals, this is from section 2, letter B, x squared minus 1 cubed, and the interval was -1 to 2. So they have to provide you with this closed interval. You haven't learned how to do open interval yet. That's actually the lesson you're going to watch on Wednesday. So the first thing we need to do is figure out where our critical numbers are. So what do we need to do to get critical numbers? We need the derivative. So we need to get g prime. So what rule is happening here? Good, chain rule. So 3 times x squared minus 1 squared times, what's the derivative of what's inside? 2x. I'm going to clean this up a little bit. 6x times x squared minus 1 squared. And we want to find where this equals 0 or is undefined. There's no denominator to worry about, so there's no undefined. If something's undefined, that's where the denominator is going to equal 0. That's not an issue here. So here's one factor to set equal to 0. Here's the other factor to set equal to 0. So x equals 0 is a critical number. And then this would factor x plus 1, x minus 1. So x equals -1, x equals 1. So I have 3 critical numbers. Now, in order for critical numbers to be potential relative max or mins, they have to fall in this interval. Do all 3 of these critical numbers occur in this interval? Yes, they do. -1 happens to also be an endpoint, so it's an endpoint and a relative or a critical number. 0 and 1 are both between. If we get a critical number that's outside of the interval, if we get x equals 5, throw it away. We disregard it. We don't want one outside of the interval. So now we have to compare the endpoint values, so f of -1 and f of 2, to the ones that are in between. So -1 is already taken care of, but we need to find out what f of 0 equals and what f of 1 equals. If we have a critical number that's not between the 2 endpoints, we can't check it. So we've got to find these values. How do we get the actual value when x is -1? That's right, we plug it back into the original. I guess I should be using g instead of f. Okay, so we plug -1 back in, we get -1 squared is 1 minus 1 is 0, cubed is 0. Plug 0 in, 0 minus 1 is -1 cubed, -1 cubed is -1. Plug 1 in, 1 minus 1, 0 cubed is 0. Plug 2 in, 2 squared, 4 minus 1 is 3, 3 cubed is 27. Which of those points is the absolute highest point on the curve from -1 to 2? This is my absolute max. Is it an endpoint max or a relative max? That's right, it happens at an endpoint, so it is an endpoint max. Which is my absolute lowest point on the graph? Right here is my absolute min. Is it an endpoint minimum or a relative minimum? Local minimum. It is a relative or local minimum because it occurs at a critical point. It is a relative minimum. Sometimes you might have 2 absolute minimums because 2 of them are equal. They're 2 points that are the lowest point on the graph, and so you would list both of them as absolute minimums. That can happen. Okay, so then move on to section 2 review. In section 2, it's the very last thing we did before Thanksgiving break. We had 2 theorems, and you got the problems done during class time in groups, the homework problems. We had Rawls' theorem, and we had the mean value theorem. We're going to review Rawls' theorem first. So Rawls' theorem says if three things happen, first thing you have to check, if the function is continuous on closed interval AB and differentiable on open interval AB, so you got to check, is it continuous on the interval, is it differentiable on the interval, and the endpoints are equal to each other. So if I plug the endpoint A into the function and I plug the endpoint B into the function, they're equal. If all three of these things happen, Rawls' theorem says if these three things happen, then we know the derivative at some point C, where C is between A and B, it won't be an endpoint. C is somewhere between the A and the B, it's not going to be an endpoint, open interval. Then there will be some point C between A and B where the derivative at C will equal 0. In other words, there's going to be a point in time on the curve where there is a horizontal tangent. There could be more than one value between the A and the B where this happens. But his theorem guarantees if these three things happen, there will definitely be at least one moment. So look on your review sheet. Let's go ahead and do, we'll go ahead and do letter B again together. B has been fun this whole time, so we're going to do letter B. So letter B says g of x equals x plus 2 times x minus 1 squared. The interval is -2 to 1. So we want to see if Rawls' theorem could be applied. So the first thing we check is this a continuous function? Well, this would make a nice cubic curve. What does an x cubed curve look like? That's right, the roller coaster. Okay, is that continuous? Yes. Is it differentiable? Are there any sharp turns, any asymptotes, any jumps? No, so it's continuous and it's differentiable. And then we've got to check, does endpoint -2 equal endpoint 1? Well, let's plug -2 in. -2 plus 2 is 0. 0 times anything is 0. 1 minus 1 is 0. 0 times anything is 0. Yes, once we know all three check, then we're looking for the moment when the derivative equals 0. So we need to make this derivative. And what rule do I see there? That's right, it's a product rule. So x plus 2 hangs out. What's the derivative of x minus 1 squared? 2 times x minus 1 times 1. Don't really have to write the 1. Plus x minus 1 squared times what's the derivative of x plus 2? It's 1, but we don't really have to write the 1. We're looking for that equals 0. What's one way to simplify that? You're right. We could FOIL this. We could FOIL this. We could add like terms and then factor that. It'll work. It's the longest way. What's another option? Yeah, that's correct. We could pull out a GCF. What's a GCF in this problem? X minus 1 pulls out. If we pull x minus 1 out of here, what are we left with? 2 times x plus 2. If we pull x minus 1 out of here, what are we left with? X minus 1. So then we're going to simplify that and get 2x plus x is 3x. 4 minus 1 is 3. So we set our factors equal to 0, so x equals 1, and x equals -1. Are both of those places where, according to Rawls' theorem, we can expect there to be a horizontal tangent? Only this one. Why not this one? Because Rawls' theorem says that C will be between open interval AB, so it will not be at an endpoint. So we disregard the endpoint value. We're only interested in the value that's between the endpoints. Good. Remember to do your checklist. Some of them on the review I gave you are going to fail. They might not be continuous. They might not be differentiable, or the endpoints might not be equal. If any of these three things doesn't happen, then you say Rawls' theorem can't be applied. The reason why, endpoints aren't equal. Or the reason why it's not differentiable at a point that's between -2 and 1. So you have to do your checklist. And then the last theorem was the mean value theorem. And the mean value theorem says, and by the way, on the AP, it is okay to write MVT for short. The mean value theorem says if I have a continuous function on closed interval AB, and I have a differentiable function on open interval AB, so you only have to check two things for the mean value theorem to be applied, continuous and differentiable. Then there will be a point C between A and B. Again, C is between the A and the B. It won't be at an endpoint. Then there will be a point C between A and B when the derivative at C equals, what is this? F of B minus F of A over B minus A. The average slope. So there'll be a moment when the instant slope equals the average slope. When the slope of the tangent line equals the slope of the secant line. Remember, the secant line is the slope that connects the two endpoints. So we've got instant slope equal to average slope. F prime at C will equal F of B minus F of A over B minus A. So we're going to do one last example from the handout. And since we've had such a good time with letter B, we're going to continue with letter B. So letter B says g of x equals 3x cubed minus 2x on the interval from 0 to 3. So, first thing we've got to check before we see if we can use the mean value theorem is it continuous? Well, is a cubic function continuous? Yes. There's no asymptotes, there's no holes, there's no jumps. Is it differentiable? Does a cubic function have any sharp turns in there? No, so it's differentiable. Don't have to worry about the endpoints. That's only for Rawls' theorem. So that means we need to find the moment when the derivative of g equals g of 3 minus g of 0 over 3 minus 0. So what is that derivative? 3 times 3 is 9x squared minus 2 equals g of 3. What happens when I plug 3 into my function? You get 81 minus 6, which is 75, minus plug 0 in, I get 0 over 3 minus 0, so 9x squared minus 2 equals 25, 9x squared equals 27, x squared equals 3. So we take the square root of both sides, and how many answers do we get? That's right, plus or minus root 3. So are both of those points that the mean value theorem guarantees will be a moment where the instant slope equals the average slope from 0 to 3. Good, that's right. We don't keep the negative root 3, only the positive root 3. Why aren't we including the negative? Because it doesn't fall between the 0 and the 3. It's outside of the interval that we are analyzing. So the only time where the slope of the tangent line is equal to the slope of the secant line that connects the 0 and 3 is at this point. So that's where the tangent line will be parallel to the secant line. Before I forget, on number 3A, when you try to find your zeros, it doesn't factor, so you're going to need to use your graphing calculator to find your zeros. So remember, if you use your calculator, 3 decimal places. So this is your review. Just, it's up to you. If, you know, the review is there to refresh your memory about all of this. The key's already up. You can check it, you know, go through it quickly just to make sure you know how to do everything before you start the pledge assignment. The pledge assignment is the one that will be for a quiz grade. So that's the one that you want to definitely give yourself plenty of time to work through. I recommend you get the review done quickly, early, check it, and then get started on that pledge assignment so that you can send me as many questions as you need to, if you need to. You might not need to. But since you're not in class, I would have given you an hour to do the pledge assignment in class, and you're not going to be in class to ask me questions. So email me as much as you need to. Okay, doke. Check in tomorrow to see the video for the new lesson. Send me your pledged assignment before that class starts.